Well, here we are getting ready to do the build. Don't want to have to yell over that all the time. So, the files will be up on Thingiverse, hopefully, God willing. And I'm trying to aim you towards the computer screen here. I'll maybe zoom in a little bit. So, this is my CR10S. It has a large enough bed to print the main frame for this in one go. Basically, your width is that where I want to start? Well, let's just look at it this way. Most of you probably don't have a CR10S, but if you do, it'll take you almost 29 hours, 28 hours, 43 minutes. And there it is on the bed as one piece. But let's get back to where many of you probably will be starting. Here's where I started. I did a second one to test the files both ways. This is on my Persa MK3, converted to the MK3S, and this would be printing the top half, so you can get the file that's divided and it says top, and then you can print the one over here that says bottom, and then basically glue the two together. And again, it doesn't matter what color PLA you're going to print in if you're going to end up sanding and filling and painting anyway. And speaking of the painting, you know how all my Robby stuff, I used to use the Model Masters gunmetal lacquer spray, which was number 1455 if I remember right. Anyway, apparently that has been discontinued. You still can find it though in some hobby shops. It's you know how old things sitting in hobby shops for a long time, their turnover isn't always there, but you can't really find it online. But I have found online that they still sell the Model Masters gunmetal in the airbrush bottle, which is a small bottle that's meant to screw right onto your airbrush and it's already thinned and ready to go. I've seen that on Amazon and eBay. And then they do make, it kind of looks like Model Masters was just getting out of the lacquers, because even that airbrush one's a lacquer. But they do still sell an acrylic version, which is their number 4681 Model Masters acrylic. And it's a gunmetal, but I haven't tried that, so I can't really tell you what the color that's like. You'll have to experiment and let me know. So let's see, let's move on. Here we are. This looks like the solid one off the CR10S5, but it doesn't matter. They're both kind of going to look the same once they're glued together. And at this point, of course, you could do sanding and filling and priming, because it's going to be a lot easier now than it is once you start gluing and assembling parts onto it. Here I am showing, let's just call these the flappers, for lack of a better term, as I talk to you through this whole thing. Here I'm test fitting one of the flappers in, and there's a rod, and you can almost see the little holes. You can use one solid long rod to slide all the way through. There is a hole in one side to do that, or you can use short little sections of rod to form that pivot point, which I did on one of them. One of the two that you just saw running, I used the jumbo paper clips and cut them and ran them through and then glued them so the rods wouldn't move. And on the other one, I used a long piece of all things, electric fence wire that I had laying out in the barn. The main thing is the wire is about, the holes that are being put in here are 2 millimeters, so you're going to want your wire about 1.5 millimeter. But you probably can find something around the house. If you haven't got paper clips, if you haven't got electric fence wire, you can print one of these little flapper keys and take it with you to the hobby shop and test fit till you find a piece of wire, they usually call it piano wire, that fits. But you can find something around the house. Hell, you could probably even strip the insulation off some AC electrical house wiring or something that would work good enough. That's showing at the out position. We have the in position. These are the parts that are going to be used to move all those little flappers. In this case, it was easier. I didn't want to wait. Let's get into this. The TT type gear motors look like this, the yellow ones. And they come in different gear ratios. This is the 48:1, so this is the fast one. And of course, being fast, that means it has the least amount of power also, but you don't need any power to do these flaps. I could have ordered the 120:1, which is the one I preferred, but I would have had to order them because of this pandemic. I would have had to order them from China, and it was going to take almost 2 months to get here. I didn't do that. So this is the faster one, and basically there's these motor mounts, a left and a right, and there's screw holes, and they're going to screw in there. And here in America I just use 632 screws short. I don't know what that is overseas, whether that's 3.5 millimeter or 4 millimeter, I don't know, something like that probably though. And you'll see the next pictures when the frame is screwed on. Let's see what the next picture shows. Yeah, here we are. I've got the frame screwed onto the motor. The next thing we're going to do is slide these cams onto the motor shaft. Just like that. You want them opposites. And the next thing you're going to want to do is slide the two longer cams in and make sure that they're opposite each other as well, and opposite of these. They're on a square drive, so just keep turning them around till you make sure every cam is aiming in a different direction. These are end caps that are going to support the very ends, and you're going to put a little bit of lube on there. I use white lithium. You could use Vaseline, whatever you got laying around. So it's going to look like that when we glue it into the back. This is a picture of the trim rings that go around the Geneva movement. That's the thing that moves with the four lights, you know. And the ring that's going to go around the star drive. They're not the same. The star drive one has a deeper lip that goes inside, and the one that goes around the Geneva has a shallower lip. And we already saw those pictures, and that's showing the gunmetal stuff that apparently has been discontinued. Unfortunately, it was the best match for Robby. I would imagine just about anybody's gunmetal paint is going to look pretty good and pretty close. Oh, this is a cast iron paint, and actually, I'm going to swivel the camera here, hang on. One of these is printed in the Model Masters, and one of them is painted, I didn't mean painted, one is painted in the Model Master, which would be this one, and one is painted with the cast iron that we're talking about that you can get in automotive stores right now, because I just bought it. And the only real difference is that the gunmetal part is pretty close, but there's a little bit of silver mixed in with the cast iron one, I guess, to give it a cast iron look. I wouldn't call it a metal flake because the silver bits are too small for that, but they are visible and they are there. But it looks pretty good. Like I say, couldn't get the Model Master, I needed to paint the other one, so here you can see a comparison in video of the two. Light reflecting in the room is going to make them look different than each other anyway, but if I try to get them at the same amount of light, you can kind of see. It's not half bad. You can kind of see the little bit of the silver in there. So you might want to go that route. You can find it in just about any automotive store. Right there. There's your number, and I don't think, did I show the whole can or just the number? There's the whole can, VHT engine enamel. So it didn't look too bad. I mean, by the time Robby was in Cars of the Stars Museum, he kind of had the silver look. In fact, he was almost a primer gray, but it's not a bad looking paint, and you can easily get that one. Okay, back to the build. So we got our little flapper keys that we were just talking about, and we want them to spring return in. The cams are going to push them out, but we want something to pull them back in to keep them in contact against the cams, especially if you're going to be running it fast. In this case, I took the spring out of an old wind-up toy and ended up cutting these strips of spring, which slide into this hole on the inside of the, see, this is the outside where you'd see it, this is inside. They slide in quite a ways, and then in the main frame there's a slot where they slide in there too. And did I write down a length on that? Just checking to see if I have anything written down here. Yeah, here I do. So on that spring steel, it doesn't have to be spring steel. If you don't have an old toy to tear apart, go to the hobby store and buy some thin brass or something, or even thin copper, or even thin aluminum. It isn't going to take much to add a little bit of spring tension to make these want to go back in. Anyway, it's about 6 millimeters wide width on the spring, and they're about 36 millimeters long. And once you have it assembled, you actually can pull the button back inside, and when you release it, it'll kind of pre-bend the spring so it'll be doing its job right. It just adds some return to keep them from slapping around. So here's one of the fronts where I've done a little bit of sanding and priming and painting. And here's the backside view where we're getting ready to install. And here we are installing it, so now you can see how things line up. There are a left and a right on both parts, and when you start fitting them, you'll see how things go. But basically, if you get the right parts here and here and here and here, they all push all the way up to this edge. And you can put a little bit of glue along the insides of these edges, so when you push them down and pop them into place, they'll stay there. Here you can see a little bit of the springs, so they go from inside the cam and right into the frame. Going to look like that. The flappers are held. You're going, well, what keeps them from going too far in? Well, they ride purposely on this cam. If you've got everything lined up right, it's going to be flat on the front when they're against the low part of the cam. When the lobe comes around, of course, that pushes them out. And here we are with some trim rings. This is the star. I'm not quite sure why the picture's here yet. Now, of course, in the real Robby the Robot, the star part should be made out of clear acrylic and then flame polished. And this represents the bulb, which is special bulb that's used in the real Robby the Robot, which is hard to find. So I decided that since you can't really print clear solid things on an FDM printer anyway, I would just go ahead and make the star and the bulb, and I would print them in white, and it's hollow in here, so when we put an LED in, the bulb part will light up. But to make them look different, and because the ring around the star and all that stuff is silver, I decided, well, let's go ahead and just hand paint the star part gold. So for this build, that's what I'm doing. You guys can do whatever you like. So there you can see the hole that goes up inside the star, where I'm going to end up putting an LED, a white LED. And this is jumping ahead to the inside of the back of the Geneva movement. We'll flip it around in a minute and you'll see the front of it. But here I'm going to end up putting 4 jumbo LEDs, white. I like the warm white with a diffused front because it looks more like a bulb when it's lit. And by jumbo, they come in different sizes. This is the 10mm jumbo LEDs. And you'll see more pictures on this in a minute. And there's the front side. I could have done some more sanding and filling, but I got arthritis. I'm old, so I stopped when it started hurting. And this is a picture of the frame that's going to hold all the mechanical parts. This is we're going to be putting some skateboard bearings down in here, or better yet, fidget spinner bearings, because they don't have the grease and they turn easier. And over here is where our star drive mechanism is going to go, and here's where our motor is going to mount. Here's a front view of what you were just looking at, the screws that go through to hold the motor in place. These cutouts are where we're going to make some contacts, because we have to make a commutator to get power to that Geneva as it spins. So step 1, screw the motor in place. If you get a motor with a dual shaft, like we just used on the flappers, you just cut the shaft off one side, because there's really no place for it to go. And again, I didn't want to wait for the 120:1 ratio, which would have been better because you need more power running the Geneva and the star drive and all that stuff. This is the 48:1, so it's the faster one, and in order to get enough power out of it, since it's the faster one, it doesn't have a lot of torque, I had to run it at the full 4.5 volts. I'm using 3 AA batteries to power this thing, and the main reason I'm using 3 is to get enough voltage to run the white LEDs, because white LEDs need a little over 3 volts to come on. So here's a picture. You can see where I cut the shaft off on that one, bolted it on. This is the back part of the star drive, and in the end you're going to want to paint this whole inside part chrome or silver, and just put some glue around there and slip it right down in here and glue it in place, just like that. And it would look like this from the front then. Of course, if you painted this before you glued it on, it'd be a lot easier because you could do spray paint. That's one of the, this is a skateboard bearing, this common bearing, the 608 bearing, which is used in skateboard wheels and also used in most of the fidget spinners. But the main difference between skateboard and fidget spinning is fidget spinning bearings they're not packed with grease, so they turn so much easier. This one was packed with grease, so I ended up soaking it in lacquer thinner for 2 days to try to dissolve most of the grease out. Because with the grease packed in there, it represents way too much load for the little motor to try to turn. But I'm going to end up putting one of the bearings here and stacking 2 of the bearings over here for the Geneva. So there it is with 2 of them stacked in, 1, 2, and 1 there. Then there's caps that go over that. There's one of the caps. You print that and you just put a little bit of glue on it and slide it right down, and put a little glue and slide it right down. And 1 more of those bearings, you need 4 altogether, is going to go inside this gear. This gear is going to form part of the linkage that makes the star drive rock back and forth. And we just slap a bearing in there and then glue this right on the top to entrap the bearing inside this gear. There I finally got around to painting mine, and just slap some chrome paint in there with a brush. You won't be seeing anything that slops over when it's assembled, so it doesn't really matter. Here we are back at the back again. Okay, now we're over working on the Geneva side. There's this axle piece. It has a super flat side on it, so it can print that flat side down on your print bed. No supports required that way. And because your prints are going this way, the axle is super strong. It won't snap or break off. So if you printed the thing vertically or something, it could tend to break on the print line. So this is your strongest way to print. Put the flat down. Just jam it on in through there and test to make sure everything is turning free at this point. This is a piece of paper. I laid a sheet of paper over here, took my fingernail, or you could use the end of a pencil or whatever you got, and creased it because I need a template that fits inside here. So I put the paper down, marked it, and then you add on a little bit extra as a tab that we're going to bend and shove through these slots. What we're building is a commutator to get the power up to the Geneva drive, so as the lights turn, the correct lights are only lit and the other lights go off. The center is the common ground, and you can, again, in the end, we're going to cut these pieces. I use some real thin tin that I got from the hobby shop. You can cut it with scissors. I laid my paper on there and just snipped around it. You can use anything you want as long as you can solder to it and as long as it's thin enough that you can easily cut it. For the center one, you could do the same thing, but what I found just digging around my workshop, if any of you guys change your own oil, I always change my own oil. I've got a Subaru Forester, and I found that the oil drain plug, you know, the crush ring that goes in the drain plug, you get a used one where they're already crushed flat. That's what this one is, a Subaru Forester drain plug crush ring. But I imagine it's about the same size on a lot of different cars. And doesn't have to be a car. Like I say, you can just cut the thing out of metal with scissors. I was just trying to make life easier for myself. And it was not aluminum, it was actually steel, so I could solder to it because I need to get a wire from that and run it down through one of the holes, because this becomes common ground for all of it. And these will become hot spots for powering up the Geneva. And what I'm showing here is the wire that's leading from that. Doesn't matter where it solders at this point. I'm not really pointing that out. Main thing is I'm showing the back. I lifted the bearings out so you could kind of see through a little bit better. But this is just a wire coming from that drain plug right there. And here are the little pieces of metal that I bent and shoved into those slots. So we want everything as flush as possible. So as the brushes are spinning around, there's nothing for them to hang up on. If they ride on this high part plastic, great, and then they can drop down in, that's fine. But you don't want an edge here for them to hang up on. If anything, you would want that end to extend over so they can come and just drop off again, because it's going to be turning the way we're holding this thing. There's one of the tabs. The other tabs there. These are the 2 positive wipers, so a wire goes from one to the other. So in this case, I'm just kind of showing that I've got ground on one side of the motor and I've got the positive tab on the other side of the motor. So when I power everything up, everything gets the same power. Here's a cap. You can notice now it's a different color than it was earlier. That's because I put everything all together and also found out the next day that there was still some grease in those bearings, which had solidified up once the thinner had totally evaporated and they weren't turning free enough again. So I had to bust that off, print a new cap. Meanwhile, threw the bearings back into the thinner, soaked them for another day to get more grease out of them. So just save yourself a lot of trouble and just buy fidget spinner bearings. This is the Geneva cam cog. It's going to fit onto the spline. There isn't right or wrong, and then you'll put a little bit of glue on there or in here and just jam it down in place. And then on top of the motor, there's this gear, and it has a cam, which is what engages all this. That'll fit right down on the motor. You can get yourself a number 2 screw. Doesn't have to be very long, 1/4 inch, 3/8, somewhere in there, and screw it right into the end shaft of the motor so it'll stay in place. At this point, you should be able to apply power to that motor and get this turning, and the Geneva and everything should spin and be working. And looking at it from the front, of course, you want it turning clockwise. So it's a good idea to test it. Here's a bottom view so you can see. This round part of the cam is what locks your Geneva from moving when you don't want it to. And this pin, when it comes around, you can see the round part stops. Pin comes around and drops into a slot, and that's what kicks it. So it kicks it, locks it, kicks it, locks it, and that's how a Geneva works. Now we're putting in that gear that we made earlier where we put the bearing in it and glued the cap on. It just slips right onto that post that's printed. And again, I didn't mention it, but I grabbed like a number 4 flat washer or something. You want to get a washer on there and your screw. Again, a number 2 screw. Length doesn't really matter. Just something to hold that in there so you can tighten down on the center part of that bearing so the gear can't go anywhere. And here I'm just showing that I took a small 3mm white LED. I put a 220 ohm resistor on it as a current limiting resistor and ran the wires down through. This is an axle for the star drive, and again you can see this big flat side. That's the flat side that would be laying on the build plate of your 3D printer so you can print it without any supports. And don't glue any of this in here, because as this shaft moves back and forth, the LED can actually stay stationary. It doesn't need to move. That way you don't have wires twisting and breaking. But here's the star where I painted it silver. Left it white and painted it gold. We're going to glue that onto the top of this, and the LED will nest up inside there. Just like that. So here's the hole, the lead and everything shoved up in there, and it's glued and centered on there. Then that shoves into that bearing that we already made on the back side, and again at this point everything should turn free. And here we are at the back side with the wires coming out. I ended up taking my wires and just bending them down, and then you could hot melt glue them. I just glued mine to the surface to keep them somewhere out of the way. Don't do it yet though, we got to put this on. This is going to be part of our linkage between here and here and here. So when you take this, we're going to be gluing it onto there. So again, you can put a dab of glue inside there or a dab of glue there, either way. I'm going to shove it on down. Position doesn't really matter at this point. So once that's down, then you can secure those wires if you wanted. And then this piece of linkage, as you can see, is going to go from here to here. And again, I take some flat washers and number 2 screws and hold it captive. The post is long enough that if you screw these all the way down, it won't pinch and bind this part if your printer's working right. And there's the assembly. So here you can see that's all hooked up. You can see where I tacked the wires down, and it's LEDs do have a polarity, and you can always find it once you have your dropping resistor on there to make sure you have it right. But usually the longer leg is your positive and the shorter leg is your negative. Some of them have a flat side on the side of the LED, and the flat side usually indicates the negative. So I just soldered the wires in with our same power that we were bringing down for our Geneva. So when I just bring power right to the motor should run, the Geneva wiper system should have power, and the star thing should light up, and all this should be spinning like crazy. So it's a good idea to test it at that point. I ended up using battery boxes you can buy on eBay that have a switch on them and hold 3 AA batteries. It was just easier than fooling with it any other way, but it also gives you an easy way to be testing everything. So there it is. Put some glue in the corners and a couple of drops near the center. Drop it down in there, line it up. The only advice I can give you on the star drive side is going to line itself up, because that front bezel, like I said, was longer, that trim ring that we did. It'll come through and line up to this piece. On the quad side, to line it up, I ended up taking the Geneva cap, which we haven't talked about yet, put it on the axle just a little bit and then wrapped some cardboard around it and shoved it in the hole. So in other words, it thinks the cap's on there. I didn't want to shove the cap on all the way because you got to be able to get it off at this point. And the cardboard is going to work like a shim while this glue is drying. So you know everything is going to dry centered and not going to bind later on. I think we've got some more pictures here. Here we go. These are the jumbo LEDs that I finally decided to use. I had ordered some clear ones, which would look more like the bulbs that are actually in Robby, but unfortunately they were the bright blue-white, and I prefer the warm white because it looks more like an old filament bulb. And this frosted diffuse thing gives it a nice softer glow rather than the ones that are totally clear which just shoot it out as a painful beam of light. So I ended up going with the frosted ones. And they're going to shove in from the back. Here you can see how one leg's longer than the other, so you know which one's negative and which one's positive. Put a little glue on the LEDs, shove them all in there, and I shove them in with the negative leg facing outward because I'm going to want to run a wire so that I can connect all the common grounds together. When they're in there and glued, they're going to look like that from the front. Again, I could have done more sanding and filling and priming to get rid of that, but yeah, I reached my limit. Now, to make the electrical connection between this Geneva thing and those little metal wipers that we cut out from our paper templates earlier, I decided to use these spring-loaded brushes that are normally used in trains. So this is the number. You can find them on eBay. The sack that they sell you will have 4 16mm long ones and 4 14mm. We're going to be using the 14mm, and you can buy bags of just the 14mm ones, but when I was checking on eBay, it actually cost more money to buy the bag of the 14 than it did just to buy this bag that has both types in them, and someday you'll probably want to use those 16s for something. See, what's nice about them is you get this metal can that you can solder to, and this carbon brush which has a real soft spring built into it, collapsible. So it gives you a really nice contact for making commutators that'll last a long time, and the carbon, of course, is self-lubricating. So here I soldered a wire to one of them. This is going to be our common ground in the center. Remember my oil drain plug rug? That's why that's going to rub on that to give me a common ground. And it just shoves in the hole. You don't need to glue it because it can't go anywhere once we assemble everything. And once all these outside legs of these LEDs are tied together, this yellow wire will solder to that, and that'll give them all a common ground. Just like that. I bridged a couple of the legs together and then just ran a wire so they're all together, then ran my ground over. So there's the ground half of the LEDs. Now, to take the positive halves, since your lights light in opposites, I took a wire from one to the opposite there, and then I'm going to take a wire from the other one to the opposite there to tie those two together. And started prepping the 2 carbon wipers we need for doing the light switching. So again, I'm just using 220 ohm resistors. It's not critical. You could use 100 ohm, you could use 330 ohm. 220 is a nice value when we're running on 4.5 volts. I don't want them super bright. I don't want to be drawing so much current that my batteries are going dead. I just want them visible, and it works quite well for that. So heat up your frame here, solder them on, keep your glob as small as possible because it's going to be shoving down in here, and see there's a slot where it can go, and if your glob got too big it would be hard to push them in. But you're going to want to follow what you're seeing here so that your lights light up in the right pattern. So kind of line your piece up the same way. If this brush is here, you're going to want to go to that LED there, and if this brush is here, you're going to want to go to that LED there. So at this point, if you applied negative voltage here and touched your little battery pack to here, you should get these 2 LEDs on, or if you touched your battery pack to here, then you should get these 2 LEDs on. And basically, when you go to shove that onto the end of the shaft that's sticking out the front, there are 3 positions that'll be wrong and 1 position that'll be right. So keep turning it until it lines up this way. All the ones that are wrong, the LEDs are going to center in a different position. There's only going to be 1 position where they send up there. And once you find that, you can then just push that puppy on in. If your printer's working right, you actually don't need to put any glue on it. If it's a little bit sloppy, put a little glue on it and shove it all the way back in there and hold it till it dries. But basically, that is it. That's it for the build. So leave your questions below. I'll try to get the Thingiverse files up there and have fun.